You know that feeling? I mean, it's the specific nightmare of every weekend golfer.
Oh, I know it well.
You're standing over what, a 3-footer? A short putt? You've hit it 1,000 times. You feel, okay, not great. But you settle in, you make the stroke.
And you look up expecting that rattle in the cup.
Exactly. And instead, you just watch the ball dive off the low edge at the last second. It lips out.
Yeah.
And you stare at the hole. Maybe, you tapped out a phantom spike mark.
Right, safe face. Or just blame your nerves. And you walk to the next tee thinking, I choked.
I choked every time.
It's the universal golf experience,
Yeah.
that dreaded low side miss. And the internal monologue, it immediately goes to character flaws. I decelerated. I didn't commit.
I have no touch.
Exactly. We treat it like it's some kind of moral failing.
Well, today we are going to completely flip that script. We are doing a deep dive into the Puttalyze Concept for short putts by Henrik Jensch. He's the director of Golf Academy 360 Degree.
And his argument is it's incredibly bold.
It is. He says those misses aren't about your feelings. They are about physics. And if you're missing low, it's not because you're a coward. It's because you failed a geometry problem.
That's the headline right there. Jensch is basically saying we need to stop treating putting as this, mystical art form based on feel or vibes.
And start treating it like a calculation.
Yes, based on the equation of motion. So the mission of this deep dive is to move us from emotion to calculation, because if you understand the math, you eliminate the guessing.
And guessing is what causes the stress. I love that promise. Knowing is relaxing.
It is.
So let's unpack this. Jensch starts with the core problem. Why do we miss low? Is it just that we're bad at reading greens, or is something deeper going on?
Well, it's a combination of things, but they all stem from a fundamental misunderstanding of the forces at play. He lists the usual suspects: underestimating slope, wrong speed.
And aiming at the wrong spot, which we'll get to.
A huge one, yes. But what's fascinating is how he ties all of these errors back to a single failure. A failure to understand the equation of motion for a rolling ball.
Okay, equation of motion. That sounds like we're back in high school physics class. I can hear listeners reaching for the skip button right now.
But stick with us, because this is where it gets really interesting. It's actually quite simple when you break it down. It's just a battle between two forces.
Okay.
On one side, you have rolling friction. That's the grass, grabbing the ball, trying to slow it down.
And on the other?
Gravity, pulling the ball downhill. And Jensch says the crucial factor, the variable that decides who wins this battle, is time.
Time. That's interesting. Usually I'm thinking about line and speed. I am definitely not thinking about a stopwatch.
But you should be. This is like the biggest light bulb moment in the research. The formula Jensch uses is break equals slope times time.
Break equals slope.
Yeah.
Times time. Okay, break that down for me. How does time create break?
Think about it this way. Gravity is a constant force. It's always pulling the ball downhill at the exact same rate. It never gets tired, right?
Yeah.
But gravity needs time to do its work. So the longer the ball is in motion, the more time gravity has to pull it sideways.
Okay, so let's play this out. If I hit a putt really fast.
The ball gets to the hole quickly. It travels the distance in a very short amount of time. Gravity has very little time to act on it.
So it breaks less. It holds its line.
Exactly.
And if I hit it super soft, try to just dribble it in over the front edge.
The ball takes a long, long time to get there. It's rolling slowly. And because it takes longer, gravity has a field day. It just keeps pulling and pulling for that entire duration.
And the ball dives.
And the ball dives. This explains why softer putts break more. It's not magic, it's just duration.
This actually explains a lot about different course conditions too, doesn't it?
It explains everything. Think about it. Fast greens versus slow greens. On a fast green, like say Augusta on Sunday, friction is lower. The ball rolls easier. But because the green is so fast, you have to hit the putt softer to stop it at the hole. Because you hit it softer, the ball is moving slowly.
Which means gravity has more time to grab it.
Exactly. This is why downhill putts on fast greens are so treacherous. It's not just that the ball rolls far, it's that it's moving slowly for a very long period of time. Gravity gets maximum opportunity to just drag it low.
That is a huge shift in perspective. I think most of us just think break is about the slope itself. Oh, this is a steep slope, so it breaks a lot.
But Jensch is saying, no, it breaks because of how long the ball is exposed to that slope. And this is why feel is so unreliable. When you rely on feel, you are subconsciously trying to solve this complex problem.
That calculus problem.
Yeah, involving friction and time variables, and unless you're a supercomputer, you're going to get it wrong. The Puttalyze concept says, stop guessing the time variable. Control it mathematically.
Right, so if control is the name of the game, we need a standard. We can't just say, hit it firm.
Right. My firm is not your firm.
Exactly. My soft might be your short. Jensch gives us a specific number to aim for, doesn't he?
He does, and this is really the cornerstone of his whole system. We need to stop thinking in feet per second and start thinking in rotational energy.
And the magic number is?
3 rotations per second, or 3 orps at the moment the ball reaches the hole.
3 arps. That sounds incredibly specific, and honestly a little hard to visualize. I don't have a strobe light on my putter. Why 3? Why not 2 or 4?
It's all about what Jensch calls capture width.
Capture width, so how big the hole actually plays.
Exactly. Imagine the cup. It's 4.25 inches wide. That's the physical size. But the effective width, the size of the hole the ball actually sees, changes based on its speed.
Right, we know this intuitively. If I blast a putt center cut, it's not going to drop.
Correct. At that speed, the effective width is basically 0. Now, Jensch ran the numbers. At 3 arps, the hole plays at its full effective width, which is about 3.5 inches.
Wait, so even at perfect speed, the hole isn't 4.25 inches wide?
No, because you have to account for the ball's radius and how it interacts with the lip. But 3.5 inches is the max capture zone you're going to get. It's a sweet spot.
So at 3 warps, it's fast enough to hold its line, but slow enough to fall in.
Precisely. It's the Goldilocks speed. Not too hot, not too cold. If you go faster, the effective hole gets smaller. You shrink your own target. Plus, lip outs go way up.
Oh, we've all seen that. The 360 around the cup that shoots back at you.
The worst. And the risk of going slower? Well, we just talked about it.
Yeah.
The time factor increases. Gravity grabs the ball and you miss low. Jensch calls 3 ERPs the perfect balance of control, capture probability, and risk management.
Okay, I'm sold on the number.
Yeah.
But I'm still stuck on the practical application. How do I know if it was 3 ERPs? I can't count the rotations with my eye.
And this is the cool part. He translates that rotational speed into a distance. 3 ERPs at the hole means the ball would roll approximately 30 centimeters.
So about a foot.
Roughly 1 foot past the hole if it missed.
Okay, that is actionable. So we're not trying to die it in the front lip, and we're not trying to jam it into the back of the cup. We're trying to hit it with enough pace to finish 12 inches long.
Exactly. It removes the decision fatigue. The answer is always 3 ARPs. You're always trying to hit it 1 foot past.
That simplifies things immensely.
Yeah.
Now let's talk about where we're aiming, because this part really blew my mind. I've always just tried to pour it into the center of the cup.
And Jensch says aiming at the visual center is a massive trap.
A trap.
A huge visual trap, specifically on breaking putts. When you stand behind the ball, your brain wants to align with the geometric center. It feels symmetrical, safe. But on a slope, the effective entry point, the door the ball actually walks through, is not the center.
So where's the door?
It's the high side, always. Jensch introduces what he calls the 23-13 rule.
Okay, let's break this rule down.
Imagine the hole is a layer cake cut into 3 horizontal sections, top, middle, bottom. Jensch argues that the bottom third, the low side, is the death zone.
Death zone is strong language. Why is it so bad?
Well, think about the physics. On the low side, the ball is effectively falling away from the center of the cup. It's fighting to stay up. If you underread the break by even a fraction, or the ball loses just a tiny bit of speed,
Gravity wins. Instantly.
instantly, it pulls it below the lip. You miss. There's no margin for error.
It's like walking a cliff edge.
Exactly. Now, look at the upper two-thirds, the high side. Here, gravity is actually assisting the ball into the cup. The ball is falling towards the hole. It widens the capture zone. So the rule is simple. Always visualize the ball entering through the upper two-thirds.
So never aim for the heart of the cup on a breaker. Aim for the high shoulder.
Always. And here's where it gets really interesting for our perception. Jensch points out that from down the line, when you're crouching behind the ball, a correct high side entry often looks wrong.
It looks completely wrong.
This is the optical illusion of the high line. Your brain is calibrated to the geometric center, so the correct mathematical line looks high. It looks like you're going to push it.
Yes. I've had this happen. I hit a putt. My brain screams, oh, I pushed that way right. And then it just dives in the side door.
That's the illusion. And it's dangerous. Because a golfer sets up to the correct high line, but their brain panics. It says, too high, abort. And right at impact, they subconsciously steer the putter back toward the low side.
And miss low. That is tragic. We are literally sabotaging ourselves because we don't trust the geometry.
It's why he emphasizes this isn't a feel rule. It's based on trajectory simulation. You have to trust the math over your eyes. Your eyes will lie to you on a breaking putt. The math won't.
Okay, so let's recap. We have the physics gravity needs time. We have the speed 3 torps, or 1 foot past. We have the target, the upper 2/3. Now we need to actually hit the ball.
Right. And he gets into the mechanics of execution. Again, he dispels a common myth. Speed control isn't about hitting harder or softer. It's about stroke amplitude and rhythm.
Stroke amplitude. What does that mean for the average golfer?
It's the physical size of the swing, specifically energy symmetry. You want your backswing length to match your follow-through length, like a pendulum. If it swings back 6 inches, it should swing through 6 inches.
So no short backswing and long guiding follow-through.
No. And definitely no long backswing with a decelerating finish, the quit stroke. That creates unstable acceleration. A symmetrical stroke gives you a consistent transfer of energy. You can't predict 3 ARPs if your stroke is random.
Right, if the engine is sputtering, the car won't go at consistent speed. And he drops a pretty heavy stat about face angle, too.
Oh, yeah. This is one every golfer should tattoo on their forearm. Face angle accounts for 92% of the ball's start direction.
92%. I think most people think the path of the putter matters more.
The path accounts for very little. Ideally, both are square. But if you have to perfect one, it's face angle. You can have the best read in the world, but if your face is twisted even 1 degree at impact, none of it matters.
So he's saying, don't bother learning to read greens if you can't hit a straight line?
Pretty much. He states clearly, consistency in face angle is required before green reading even matters. If you can't start the ball on your intended line, math can't save you.
That's a tough pill to swallow, but it's fair. There's also one more technical detail, launch dynamics. The ball shouldn't just skid, right?
Correct. This is granular but important. A golf ball sits in a tiny depression in the grass. To get a pure roll, you need to lift it out of that micro hole.
So we aren't hitting down on it.
No. The ideal launch angle is 0.75 degrees to 2.5 degrees positive. You're actually hitting slightly up on the ball.
Just slightly.
Just slightly. It lifts the ball out, minimizes the skid phase, and gets the ball rolling true as quickly as possible.
Okay, so we've got the theory. The physics, the speed, the aim, the stroke. How do we put this all together on the course without slowing everyone down?
Jentsch provides a very structured 4-step Puttalyze routine. The goal is to stop guessing and just execute a program.
Walk us through it. Step 1.
Step 1 is analyze. This is just data collection. You're a surveyor. You measure the slope, estimate the distance, find the fall line, judge the green speed. Just cold, hard facts.
Okay, no emotion. Step 2.
Step 2 is calculate. You process the data, you select your target speed, which is always 3 EPS, and you determine your aim point based on that time factor. You're locking in the geometry.
Got it. Step 3.
Step 3 is visualize. And this is specific. You aren't just vaguely seeing the ball go in. You're picturing it entering that upper 23 zone.
The high side.
The high side. And this is critical. You visualize it slowing into the hole with a 30-centimeter or 1-foot overroll. You see it dying into the cup, but with enough pace to go a foot past if the hole wasn't there.
I really like that overall visualization.
Yeah.
Forces you to commit to the speed.
Exactly. And finally, step 4.
Execute.
Execute. You switch modes. Analysis is done, calculation is done, now you switch to athletic execution. You trust the calculated line with no manipulation.
That no manipulation part is the hardest, isn't it?
Yeah.
That's where the brain sees the high line and screams abort.
It is the hardest part. That's why the routine is so important. If you've done the work in steps 1, 2, and 3, then step 4 shouldn't require thinking. It's just output. Your brain has to switch from analyst to athlete.
It makes putting a measurable system. If you miss, it wasn't bad luck. It was either a bad calculation or a bad execution. Both are fixable.
Exactly. It's not an emotional roller coaster anymore. It's a science experiment.
So, to bring this home, the listener heading out to the practice green this weekend should stop just raking balls and slapping them at the hole.
Absolutely. You need to practice with intent. Start with speed. Put a tee 1 foot behind the hole. Your goal isn't just to make it, but to have the miss hit that tee. Find that 3 or its pace.
And start aiming higher.
Yes, force yourself to aim at the high side. It will feel wrong. It will feel uncomfortable. But you have to recalibrate your brain to accept that the high line is the pro line. Gravity is your friend on the high side. On the low side, it's your enemy.
I think that's the biggest takeaway for me. We spend so much time fighting the golf course. But Jench is saying, if you get the geometry right, the forces, gravity, and friction will actually do the work for you.
That's the beauty of it. You control the start line and the target speed, and you're essentially building a chute for the ball to ride gravity right into the cup. You aren't hoping it goes in, you are allowing it to go in.
Allowing it to go in. I love that distinction.
It's a total shift in mindset. Recreational golfers compensate. They hit it firmer to take out break because they don't trust the read, Jench says. Replace compensation with calculation.
And don't forget that 92% stat about the face angle.
Right. It raises an important question. Are you practicing your read or your stroke? Because until that face angle is stable, the read is irrelevant. You can't solve a math problem if your pencil keeps breaking.
That is a perfect analogy. We've covered a lot here. The physics, the speed, the aim, the routine.
It's a comprehensive system. It moves putting out of the realm of touch and firmly into the realm of science.
So here's my final thought for you to chew on. Next time you're over a putt, feeling that spike of adrenaline, asking yourself if you have the nerve to make it, just stop. Take a breath. Remind yourself the ball has no idea how nervous you are.
That's right. The ball has no feelings.
The ball only knows physics. So the question isn't, are you brave enough? The question is, are you geometry compliant? If you control the variables, gravity works for you. If you don't, it works against you. So ask yourself, are you letting physics help you, or are you fighting it?
That's the question.
Thanks for listening to this deep dive into the Puttalyze concept. Go out there, trust the high line, and let gravity do its job. We'll see you next time.